As we look at this limit, as x goes to infinity, the top's going to go to infinity and the bottom's going to go to infinity. So we have the indeterminate form infinity over infinity, so L'Hopital's rule would apply. So let's go ahead and use L'Hopital's rule. So we have the limit as x goes to infinity. We need to take the derivative of the top, that's 2. The derivative of the bottom, we're going to think of this as 2 and then x squared plus 5x plus 5 to the 1/2. So derivative of the bottom, we'll do the power out in front. It'll cancel with that 2, and then we'll decrease the power by 1. That'll make that to the negative 1/2. And then the chain rule applies, so we need to multiply by the derivative of what's inside. That's going to be 2x plus 5. Okay, now that we look at that, we see this negative exponent, and so we're going to move it to the top so that it's not negative anymore. I'll put that down on the next line. No h over this one because this is just simplifying or re-expressing this in a different form, so we don't have a negative exponent. So it's going to come to the top and be x squared plus 5x plus 5 to the 1/2 on top, and then the bottom has 2x plus 5. Okay, now as we try and take the limit, the top is going to go to infinity and the bottom is also going to go to infinity. So we still have an indeterminate form, infinity over infinity. So let's apply L'Hopital's rule again. So we've got the limit as x goes to infinity. Let's take the derivative of the top. We move the power out in front. That'll cancel with the 2 that's out there. We'll decrease the power by 1. And so that's going to be to the negative 1/2. And then we've got the chain rule multiplied by the derivative of what's inside. The derivative of what's inside is 2x plus 5. Now we go down to the denominator and take the derivative of the bottom, and that's just 2. Okay, now we're going to express that without a negative exponent. And so we'll move that down to the bottom. So the top, the numerator is 2x plus 5, and the bottom is 2 times x squared plus 5x plus 5 to the 1/2. Hey, wait a minute though. That is actually just what we started with, because this is what we started with, and if we rewrote this as a radical, it would be the square root. We are back to where we started. So if we try and use L'Hopital's rule, this would just cycle, because when we take the derivative, it would end up equaling this next piece, which rewritten was like this, the green. And then when we take its derivative, then it's back and rewritten like the first. So this is called a cycling function. It just keeps going through this cycle of, they end up being, when you take the derivative and you simplify it, then it ends up being the next one, and then you go back to where you start, and then it just keeps going. So it's called a cycling function. So L'Hopital's rule is no good to find this limit, because we can't get it to be anything that then we could evaluate. So this is one case, a cycling function, where L'Hopital's rule is not the way to do this. And it typically will happen when you have a radical, because notice this radical was in the denominator, but when we did derivatives at top and bottom and simplified, then the radical ended up in the numerator. And then when we did derivatives using L'Hopital's rule and simplified them, then it ended up back in the denominator and caused the cycling. So how are we going to solve this then? We are actually going to solve this using what we would have done had we not known L'Hopital's rule. So let's rewrite what we started with. Limit as x goes to infinity of 2x plus 5 over 2 square root of x squared plus 5x plus 5. Remember when we were looking at these limits at infinity that we used the trick of multiplying top and bottom by 1 over the highest powered x in the denominator. So looking at the denominator, we would want 1 over the square root of x squared, because this is the highest powered x, but it's underneath a square root. Since the numerator does not have the radical, let's go ahead and simplify 1 over the square root of x squared to put the equivalent thing. That's just 1 over x. So we can now use this to, we'll distribute that through and then we'll see what that limit is. So we got the limit as x goes to infinity. Multiplying this x through, that'll make that 2 plus 5 over x. And down in the denominator we have the 2 out in front, but this is underneath a radical, so we can multiply it under the radical, and that'll make that 1 plus 5 over x plus 5 over x squared. Now we can let x go to infinity. Fixed numerator, denominator going to infinity makes the fraction go to 0, and we've got 3 of those that are going to go to 0. And then what we have left is 2 over, as we're looking at that in the denominator, it's 1 times 2, so 2. So that ends up equaling 1.